Welcome to my Dash scripting tutorial. In this tutorial we will be looking at how to create script files in a POSIX compliant shell. I do presume a basic knowledge of the command line and will be focusing on the scripting aspect only. All of the features you learn here will work in any POSIX compliant shell, so they will also work in the ever popular Bash. I will start the session by showing how to create a script file and how to run it in the interpreter. Next, I will show you what flags you can set on the interpreter to modify its behavior. Then, as the final topic, I will show you how to pass parameters to a script to modify the behavior of the script. Finally, I will be giving some examples to show how even this limited feature set can already be used to write useful scripts. I will try to make the examples in this tutorial meaningful so that it doesn't just seem like a theoretical exercise. So let's create our first script file. In its simplest form, a script file is nothing more than a sequence of statements that you could have individually typed into the terminal yourself. So here I'm using xed to create a simple text file with just an echo statement, which is the most basic hello world script you can make. And then I can invoke the shell and pass the script as an argument, and you will see that it runs the echo statement because it gives me the output hello. Now, since Bash is backwards compatible with the POSIX specification, we could also pass this script to Bash and run it. Now, normally on Windows, we use the file extension to determine which application gets to open a certain file. So, for instance, if you have a zip archive, the file name would end with .zip, and if you would double-click the zip file, then Windows would look up which application is registered for that specific file extension, and then it would start, for instance, Explorer or WinZip or 7-zip or WinRAR or whatever application you've configured to open zip files. Now, under Linux we have a little bit of a different method. Under Linux we add a shebang header to the beginning of the file. Normally, if we start a line with a hash, then it becomes a comment. So if I run the file now, you can see that the echo statement is no longer executed because the shell interpreter doesn't interpret as code but as a comment on the code. Comments are primarily intended to describe what code does, especially if code gets complex, but they're also often used by software developers as part of the development process to turn off certain chunks of code. So the shebang header has to be the first line in a file, and it's a little bit of a special comment because after the hash you get an exclamation mark and then a fully qualified path to the shell interpreter that should run the file. And as you can see, xed looks at the shebang header to determine what kind of file it's dealing with and how it should highlight the code. So now I've defined that this script should run in the Debian Elmquist shell. Now if I run it like this, then it will still run in Bash. And so let me show you that. If I add the dirs command, the dirs command is specific to Bash. It's internal to the born again shell. It's not part of the operating system. So here you can see that the command works because it gives output. And if I run the command with the Elmquist shell instead, then the command does not work. The typical way to run a file under Linux is by making the file executable and running it directly. So as you can see, I get a permission denied now because it doesn't have execution rights yet. So now the file has execution rights and I can run the file. And as you can see, it's been run in the Debian Elmquist shell because the Debian Elmquist shell doesn't have the dirs command. Now the shebang header is very important. It's good form to add it because if we leave it out and now I run the file, now suddenly it's being run in Bash because I'm currently in the Bash interpreter. If instead I open a different shell and I open the file, now suddenly it's run in the Debian Elmquist shell, which is a little bit tricky because if you were to share this file with other people, you don't know what shell another person is running. So if you don't add a shebang header, then the script might not run in their system simply because they have a different way of operating. So now that we've seen how to create and run scripts, let's discuss the various flags we can set on the shell interpreter to modify its behavior. Now this is not a complete list of all of the flags that are available to us. The error flag can be used to tell the shell interpreter to stop executing a script as soon as it encounters an error. By the way, all of these flags are off by default. The no execute flag can be used to tell the shell interpreter to check the syntax of a file, but not to run it. The undefined variables flag can be used to tell the shell interpreter to stop execution as soon as it encounters a variable which hasn't been defined but is trying to be used. The last two flags can be used to get additional debug output as to the state of the shell interpreter as it's processing the file. The error flag and the undefined variables flag, I would recommend always putting them on because they greatly increase your capacity to find and fix bugs in your code. The no execute flag, I will be showing you how that can be made useful after I've discussed parameters, and the last two are mainly useful for debugging. So let's look at the various ways which we can set these flags. You've already seen that we can run a script by calling the shell interpreter and passing in the file as an argument. Now as you can see here, you can simply pass the flag, and this is the simplest way to do it, to pass the flag to the shell interpreter before the file. And as a result of enabling the error flag, you can see that the echo hello statement is no longer executed because the dears command hasn't been found, and that's an error. And the second way to set a flag is by specifying it in the shebang header. Once we set it in the shebang header, we can execute the file normally, and as you can see, it's enabled. The last way to do it is using the set command. So in the file itself, at any point, we can set a flag, and from that point onwards, that flag will be enabled. It's also possible to turn the flag off again. So here nothing happens because it's first turned on and then it's turned off again. This might be useful in case if there is a line in the code that may cause an error, but it's not a critical error, so the script should continue anyway if the error occurs. Now that we've discussed how to turn them on and off, the question is which method should you be using to turn a flag on or off? Now for flags that you always want to turn on, regardless of how the script is invoked, I would recommend setting them in this way, because there's no way to turn these off, and it's part of the specification of the source file. Now if you have a flag that you want on by default, but you still want to be able to turn it off, then you could set it in the shebang header. So in this case, you can see that it's printing every line as it encounters it. So the flag's been turned on. But if I run the file like this, then it's turned off. Now if you don't want to modify the source file, you just want to turn on a flag once, but you don't want it to be permanent, then I recommend passing it as a parameter to the shell. This one's especially great for the verbose flag. If you run a script and there's a problem in it and you don't know where it stops. Now in this case it's pretty obvious, but some scripts don't have output most of the script. They're just doing a lot of tasks, and if the script then fails execution at some point, then you don't know which statement has been reached and which ones haven't. Well, this would be a great solution to that. When we invoke a script, we can pass in a number of parameters. These parameters will be made available within the script itself in the variables 1 to 9. The script file itself, the file that's being executed, will also be made available in the variable 0. A POSIX shell also makes some additional variables available, such as the number of parameters that have been passed, and a single variable containing all of the parameters at once. So let's modify our script to use some parameters. First, I am going to print the number of parameters. Then I'm going to say hello to every parameter. Then I'm going to print just the first one and just the second one. So here we can see that I invoke the script with two parameters, Fred and Barney. And we also have usage of all of the parameters at once there. Now if I remove one parameter, an interesting thing happens. Here we can see the unused variable flag at work. We're referencing the second parameter here, but it hasn't been set, so it's complaining. I'm going to remove the error checks for now, just for this demo. And you can see that if the flag isn't set, then it just prints nothing for where there is a parameter. And if we run it without any parameters, this is the result we get. Now this gives us an interesting situation where we can check how string escaping work. As you can see, I now have two parameters, A and B. But if I want to send a space as part of a parameter, then I need to escape it. And now you can see that the first parameter is both A and B. Now there's other ways to do this as well. Now, if you're used to programming in other languages, then you might think that if I type something like this, that this defines a string literal within the quotes. But it's actually a little bit different how it works. In shell scripting, it's more of a toggle that you turn on and off. And as you can see, the quotes don't show the endpoints of the string, but they basically toggle a space escaping mode. Now it is possible to use variables in double quoted strings. It is possible to use variables in double quoted strings. In single quoted strings that does not work. You can see that this is literally these are environment variables. Well, not really. I think this variable is made available by the shell interpreter itself. So as you can see here, it literally prints the variable, while in a double quoted string, it is substituted with the actual parameter, which is the current location. I am not going to go into the ins and outs of character escaping in the shell, but I did promise that I would show usage of the noExecute flag. So if we run the shell script with the noExecute flag, you can see that nothing happens because it's syntactically correct. So let's make the file incorrect syntactically. Now you can see that at line number 7, and I don't have line numbers turned on right now, that the word do is used, and it's not expected at this point, and that this is a syntax error. Now normally, if we'd run the file, you can see that even though the file is not syntactically correct, it still executes it, but it just crashes when it reaches the error. So one way we could get around this So what did I do here? What I said is halt on errors, so I set the error flag, and then the first command after that was to run this file in the Debian Elmquist shell interpreter. Don't execute the file, just compile it, And as you can see, it throws an error because it doesn't compile. And basically what I've achieved here is with these two statements, I've ensured that the shell script will not be executed unless the entire script is syntactically correct. In my opinion, if we were to redesign shell scripting today, we would probably have this behavior on by default. In fact, I think there's a lot of things that would be different. It seems as though the lessons we've learned in software development haven't translated to shell scripting very well. For instance, the fail and error flag and the unused variable flags should be on by default. The reason why this hasn't been done is probably because there's a lot of scripts on servers right now that don't expect this behavior and that wouldn't operate on under these more stringent requirements. So making changes to the default behavior of shell interpreters would cause all sorts of problems on production servers. But let's look at some examples. The first example I want to give is how to make a simple installation script. Let's say I want to run the application FowlLight. Now, as you can see, it's not currently installed, and Ubuntu suggests a command I can use to install it. Now, normally if you run this command, then it asks for permission to install the software once it's figured out how much disk space it's going to take. Now, that's not very useful for an installation script, so we're going to add the yes flag to automatically answer this question with yes. So as you can see, now it automatically installs unattendedly, and this gives us the option of creating an installation script that installs a bunch of packages completely unattended. Oh, it's already done. So let's check out FowlLight. Now this is a useful application which you can use to enter a disk or a location on a disk. It will scan the file system and it will show you what the large directories are in a pie chart. And you can actually click on one of the locations and it will show you a further division of the disk usage. Anyway, this is not about FowlLight. So the first thing we need to do is make sure that app gets the most recent list of the contents of every repository. And then we just install some packages. My favorite window manager and an alternative run dialog. And let's also enable the Ubuntu firewall. This will close all your ports and make your computer more secure. And now we can just run the script and the packages will be installed. So if you install a new computer, then you can just run the script and you'll have all your favorite packages. In this case it's just 2, so it doesn't make a whole lot of sense to automate this task. But if you have, say, 30 applications which you regularly use, then it's quite convenient to have this in a single script. Also, you can put the script in a Git repository and put it on GitHub, and you'll be able to access the file anywhere you go. And if you're ever working on another computer, and you do of course have the rights to install software, then you can just download the script and run it. Okay, so let's go to the ICE window manager to see how it works. On the login screen, you can select a different window manager. The ICE window manager is ideal for keyboard users because it comes with a very large list of keyboard shortcuts out of the box. It also has a very easy way for configuring your own keyboard shortcuts. The other main advantage of the ICE window manager is that it uses very little memory. Normally on a cold boot it uses somewhere between 120 to 140 megabytes. It's a little bit more now because the system was already running when I logged out. XFCE on the other hand uses about 400 megabytes, Windows 7 in comparison on a cold boot uses about 2 gigabytes of memory. That's 2 gigabytes of memory used by the operating system that's not available to the applications you're running. This is also one of the reasons why Linux is often used for all the computers. So the second script I want to show is going to be a script that focuses an application regardless of which desktop it is on, and regardless of whether there are any windows in front of it. Now, it's not that complicated of a script to write, because the functionality is already built into X with the WM control script. So I'm going to create a file and give it execution rights. And all the file has to do is call the WM control script. And the window it's going to focus is going to be the first argument we give to the script. Now, normally you'd have to run the script like this. But in this case, so you only need to qualify, fully qualify, or partially qualify the name of the script file if it's not on the path. Now, I haven't discussed the path yet, but what I will say is that Linux 19 by default checks your home directory to see if there's a bin directory there, and if there is, then it adds it to the path. Now, for this to work in your case, you might need to log out and log in again first, but I already went through that hoop before I started recording, so I won't have to do that. Now, I also wanted to show you that now Firefox is behind another window, but I can still do I can still run the script, and it jumps to the desktop containing the application and brings it to the foreground. Now, it's not perfect, because what it does is it scans the titles of the windows to determine which one it should open, and there may be multiple applications which have the search string in the title, in which case it'll simply take the first, whatever that means for the script. But still, I think this is a useful script you can use in case you don't know on which desktop or behind which application you left a certain window. Well, I hope you like this, and I hope to see you in the next episode of this tutorial.